Okay, our first log rule, our first property of logarithms, is what we might call the log of a product rule. If we have any positive numbers and any base that we can use as the base of a log, then the log of the product is the sum of the logs. Sometimes we phrase this property as the log turns multiplication into addition. The log of a product becomes the sum of the logs. Now, this is really weird, right? This is very different from anything that we've met before, like the distributive property, where we started with addition and we ended up with addition, or multiplying powers of the same thing, right, where we can distribute an exponent across a product. This is very different, and to see why, we're going to make that notational move that I mentioned earlier. We're going to say, write x as the base to some power, so the log of x is m. Y is the base to some other power, so the log of y is n. Then x times y is the base to the m power times the base to the n power, which is the base to the m plus n power. Which means if I take the log of x times y, well, x times y is the base to the m plus n power, so the log of x times y is m plus n. But then m is the log of x, and n is the log of y, which is the theorem that we wanted. So as long as x and y are already positive numbers, this rule applies. We can split up the log in this way. How do we use that? Well, we use it in two different ways. It might be that we have a log of a product, in which case we want to use the rule going from left to right to say that the log base 4 of 5 times x squared is the log base 4 of 5 plus the log base 4 of x squared. So the log of the product becomes the sum of the logs. We might also apply this rule in the other direction, where we have a sum of logs and we want to combine it into a single log expression. So here we have the log base 3 of x plus the log base 3 of x plus 1. Well, that combines to give us the log base 3 of the product, x times x plus 1. If we liked, we could apply the distributive property in that argument, but it's not necessary. So we can use this log rule in two directions. If we have a log of a product, we can split that up as a sum of logs. If we have a sum of logs, we can combine that as a log of a product. And it will turn out that both of these moves have their uses.